Welcome to the deep dive. Today we're going to try and get a handle on this incredible atmospheric split that's basically cutting Europe in two.
It's a total bifurcation. Yeah.
Right. And it's for this really crucial window, December 19th through the 28th. You have this, a massive storm system in the west.
And then a severe deep freeze in the east, a continent of two extremes.
So what's kicking this all off? The data points to a really unusual event.
It does. The core driver is an early and very major sudden stratospheric warming, an SSW, that happened back in late November. Our sources are calling this a 70-year statistical outlier.
A 70-year event. And that timing is key, I imagine.
The timing changes everything. It completely throws off the typical winter models.
Okay, so let's break down that engine of extremes. When we hear SSW, most people think surface weather. This isn't that, right? This starts miles up.
Miles up, exactly. Think of the polar vortex, the system that normally keeps all that bitter Arctic air locked up over the pole.
Right, like a spinning top keeping everything contained.
Perfect analogy. And this SSW is a massive, rapid temperature spike. We're talking almost 50 degrees Celsius in the stratosphere. It creates a huge high-pressure zone, an anti-vortex.
So it's like a brake being slammed on that spinning top.
It's more like it hits the top and makes it wobble and buckle. That's the polar night jet breaking down.
So how does that chaos, way up there, translate into a blizzard down here?
Well, that high pressure doesn't just stay up there. It actually propagates all the way down to the surface, and it sets up a huge atmospheric roadblock.
A blocking pattern.
Exactly. It forces the jet stream south and literally splits the continent. All that frigid air is now free to just spill out.
And this particular collapse is not happening in a vacuum. There are a couple of other global factors giving it a push, aren't there?
There are, yeah. We have a weak La Nina and what's called an easterly QBO, or quasi-biennial oscillation. Yeah. The synergy is what's fascinating here. Historically, that specific combination strongly favors a weaker polar vortex. So you put all that together, and you're not just getting a cold snap. You're setting up two opposite but very predictable disaster zones.
Right. So now let's look at those two realities on the ground. Let's start with that deep freeze in the east, central Russia, Moscow.
For them, you can just throw the standard averages out. The real risk here is a full-blown beast from the east scenario. We could see temperatures plunge 10 degrees Celsius below the 10-year normal.
But the real infrastructure threat isn't just the cold, is it?
No, it's the snow. In the Urals, we're tracking what we call hazardous heavy snowfall events. That means at least 20 millimeters of precipitation in just 12 hours.
And that's wet, heavy snow.
Exactly. That's the stuff that brings down power lines. It causes cascading failures because of the sheer weight.
And this Arctic outbreak goes all the way to the Pacific, right? Kamchatka is seeing something pretty extreme.
Oh, absolutely. Extreme cyclonic activity. They're forecasting hurricane-force wind gusts up to 33 meters per second, a deep freeze with incredible energy.
Okay, so now let's flip the map completely. The West. It's a totally different story.
Total contrast. While the East is freezing, Western Europe is running 5 to 10 degrees Celsius above normal. This is a classic maritime storm regime.
Driven by what?
Deep Atlantic troughs. It's pulling in moisture and energy, leading to heavy rain, high winds, and a serious risk of flash flooding. If you look at the Scottish Highlands, they could get up to 200 millimeters of rain.
Wow. And this collision of weather extremes seems to be timed perfectly to intersect with, human factors. Logistical nightmare.
It couldn't be worse timing. You have coordinated industrial action strikes, DHL ground handlers at London Luton, SAS cabin crew at Heathrow.
And they're targeting the absolute peak travel days.
The peak days. You've got storm delays, and then you have major staffing walkouts right on top of it. It's a recipe for chaos.
And there's a place where you can almost see this collision happening in real time, right?
Yeah.
In the Caucasus.
Precisely. It's the perfect example. In Georgia, on the cold side, they're facing a high avalanche risk. Then just next door, in Azerbaijan, on the coast, they're expecting winds up to 33 meters per second, threatening infrastructure.
So we take a step back from this one event. Is this just 70-year bad luck? Or is this volatility part of a bigger picture?
This is symptomatic. The global average temperature is now 1.5 degrees Celsius above pre-industrial levels. That extra energy drives volatility.
It makes the whole system less stable.
Exactly. We're trading stability for extremes. These intense dual hazard systems are unfortunately becoming the new normal.
It's the key takeaway for you listening, especially if you're in civil planning or infrastructure management. The focus has to be on resilience.
Resilience specifically to icing. It's about handling the stress of those rapid phase changes. that wet snow followed immediately by a flash freeze. That's the infrastructure killer.
And this isn't ending with the new year.
No, this disruption is expected to persist well into early January 2026, and that raises a pretty important strategic question.
Which is?
What does it mean for the second half of winter if the polar vortex, after this spectacular collapse, suddenly strengthens mid-season? That rebound could deliver a second and equally disruptive wave of extremes.